Welcome to Xcoder videos and the third session of the Microhard videos that we started a few days ago. In the second video of this series, we created several components for Microhard, the exclusive OR, the OR, and the AND gate. And that opened up some new tasks for us that we're going to be doing today, not for B and for B and or for W. And we'll take a look at each of those in just a moment. But first we want to look at syntax with regard to buses, because we're going to start using buses in these components in this video. So that we have opened up the workspace for Microhard, and we're now looking at the syntax section of the manual. And so let's just scroll down here so that we can get all of the buses information here and take a look to see how buses are specified within a design document. So far, we've looked only at single pin components that involve only pins and not buses. But now we're going to be getting a little bit more complicated with, and most of the components, if not all of them, will be using buses. Buses can be written like this or defined like this, and the inputs, the N bus 1, open bracket 8 and close bracket, defines an 8-pin bus. The same is true of N bus 2, and then N bus wide defines a 16-pin bus, and then the N pin 1 specifies just a single pin, a single input pin. Output buses are defined the same way the input buses are defined, by adding a bracket and the size of the bus within the brackets, just like this. When we specify buses in the document, we can connect buses of equal size directly like this. In bus 1, which is 8-pin bus, to out bus 1, also an 8-pin bus. Single pins inside the bus can be selected and connected as well. So if we want to just connect one output pin, we want to connect one wire within the bus to an output pin, we would do something like this. In bus 1, open bracket, and then the wire number, which is 1 based, not 0 based. So this is the third wire in the bus, and we connect that to the output pin just like that. It's also possible to select not only just a pin, but you can select a part of a bus. In this example, the 8-bit bus in bus 1 is connected to pins 9 to 16, starting with 9, ending with 16, inclusive of the out bus wide bus. And you can also do input. We can also specify a range of pins from an input bus like N bus 1, 1:8, and that's in this case, because it's just an 8-bit bus, then N bus 1, 1:8 is identical to N bus. And then finally, we see that you can connect a single pin to multiple uh, wires within a bus like this. And in pin 1 connects to wires or to points 2 to 4. These three wires in outbus 1. You can't do that the other way. On outputs from a bus, each wire must connect to a single pin in the syntax. There's no way to connect several wires at one time to the same pin. And the last thing that that we want to note is how when a bus is used in a specification, it's going to be defined in such a way that pin 1 or that wire 1 is the lowest order of magnitude in the buses, and pin 8 is the highest order magnitude. We will be looking at binary arithmetic and logic a little bit later, not in this video, but in another video later on. But right now it's good to know that in this case, this is wire number 1, then 2, 3, and 4, which are all 1s, and then 5, 6, 7, and 8, which are all 0s. And that's how you would reference each of those lines in the bus. And I think that gives us a good understanding of the use of buses. Let's go back now and look at the components that we've been given to define. All right, here is the not 4B. This is a 4-bit not specification. The not 4B element is a bus version of the not gate, and it applies the not operation to every bit in the bus. There are 4 inputs, 4 outputs, and it is graphically represented in the way that you see here: in 4, out 4, and the truth table for the not 4B is as you see it here, where in this case these are all the inputs, all the possible inputs for 4 pins, or at least 6 possible inputs for the 4 pins. It's not all, that's not all the possible inputs, but it is just a sample of them. And you'll notice in the output, everywhere there's a 0, the output is 1. Everywhere where there is a 1, the output will be 0. So what you're seeing is pin 1 is just flipped from 0 to 1. Same thing is true of pin 2 or bus 3 and bus 4 there. And so that's how to do the not 4B, and 4B is going to look almost identical to that. Except that there are 3 buses. In this case, the 3 buses are the N1 4, N2 4, and then the outputs out 4. There are 4 outputs, 8 inputs, because each AND gate has 2 inputs. And so that is how the bus, the component is, this is how the component is represented graphically, and this is the truth table for it. And it looks like they've given us all representations here of the output. And I don't know if going back, I thought not for B didn't give us all of them, but maybe it does. But no, with four inputs, that should give us, there should be 8 different possible combinations to it. And so they've missed a few of the cases. And then finally, the uh, W, R4W, this is called a four-way OR specification. And I want to see what the difference is here. The AND is a 4-bit AND specification. R4W is a four-way specification. And I see what this is. This is an R component with 4 inputs and 1 output. And so we it looks exactly the same way that a regular OR works. If any of the bits are 1, then the output will be 1. If all the bits are 0, then the output is 0, exactly like a normal OR. So let's go ahead and let's start with this one. This looks like a little bit easier one to do. I tell you what I will do. I'm going to pause the video for a moment and draw up a design for these tasks, and we'll come right back to the video to finish out here. So please give me a moment, and of course you won't even experience any lag. Okay, we're back, and let's take a look at what I have defined or designed for the R4W. This is a bus version of the OR gate. It has 1 output, 4 inputs, N1, N2, N3, and N4. If any one of these is 1, then the output should be 1. And fairly simple. It's a fairly simple diagram. We just take 2 ORs, or pins 1, pin 2, and another one, or pin 3, pin 4. And then these are going to be 1 or 0 based upon the output, based upon what these are. And then the last OR, this third OR here, is going to take the output from these 2 OR gates. And if either one of these is 1, it's going to send out a 1. The only time that this will be false is when one of these 4 bits is when all of these 4 bits coming into the circuit is false. So let's go into our design tab and see if we can't implement this design. And it looks like sometimes I keep forgetting how to move to the parts. So we've got our inputs defined and our outputs defined. Let's take a look at the parts. And this time I'm just going to be interested in getting the design prepared. And we've got 3 OR gates. So we'll have OR 1 is an OR. And I want to try this. OR 2 is an OR. And the autocomplete is control space. And I guess you press enter. That's a lot of work just for a two-letter word, so probably not useful there. Then OR 3 is an OR as well. And that's all of the components for this component that we're designing. Let's go down now and wire this up. We'll clean that up a little bit. And the wires are going to be ends in one like this, in one will tie to OR 1, and now we can hit Control Enter and get that. That's a little bit better there. And N2 is going to the same OR gate according to my diagram to pin 2. And then N3 is going to the second OR gate, N1. And tell you what I'm going to do is just going to press that. Let's see. I need to put a comma there, don't I? And this is going to be in 4 to OR N2. Now, the output from OR 1 and OR 2 to OR 3. OR 1 dot out to OR 3 dot in, and let's just get a copy of that. This is going to be OR 2 dot out to OR 3 dot 2. And finally, we've got OR 3 dot out to our output port. And let's try that. Control Enter. We passed. Notice there are 16 test cases for this output, and everything is a 1 except for that first one there, 0, 0, 0, 0. So that is excellent. And we click OK. And now we've got a new briefing. You unlocked a new briefing. Have you met Ted? Let's find out what this has to say about Ted. I know that doing bus versions of finished design can be tedious, and we don't want to waste your mind on monkey work. Gladly, I was able to hire an intern. Oh, that's good. Who will help you out with that. Ted is a novice, and therefore don't expect him to come up with any original designs, but he will assist you in creating any bus versions similar to ones you already created. Ted gets the work, you get the fun. Well, that sounds interesting. I wonder how that's going to work. Let's go down to the and 4B. Let's try that one out. And hit enter to get over into the specification, and let's take a look at our design here for the and 4B. And this is a little more complicated now. We've got 4 buses, the N1 bus, the N2 bus, and the out bus. And the N1 bus is going to tie to the input of pin 1 on each of these 4 AND gates. The N2 wires will connect to the input of pin 2 of each of these AND gates, and the output of these AND gates will be tied directly to each of the wires of the out 1 bus. So it's a fairly simple design. Let's see if we can't implement that in the Design tab. There we go. And we're going to come here and specify the parts that we need, and the parts that we need are 4 AND gates. So we're going to have AND 1 is and let's just duplicate that a few times. And fix the label names. Okay, that's all the parts that we need. And now we're going to come in to wire it up. And let's wire the N1s to N1 to 4 first. And we'll go like this. N1 to and 1 dot N1, and let's we're going to skip a line. Uh-oh, I see something I did wrong here. This is N1. And this is going to be N2. The first will be AND 1, AND 2, AND 3, and AND 4. Same thing here. And 1, and 2, 3, 4. This is going to be input 1, 2, 3, 4. Two, 3, 4, and this is going to be tied to N1 and N2. All right, that's all of the inputs. Now let's do the outputs. Uh-oh. And we've got and we're going to have and 1 dot out 2 out dot 1. That makes sense, hopefully. 1, 2, 3, 4. This is out 2, out 3, out 4, and 2, 3, and 4. Not giving a lot of explanation about what we're doing. I hope this is easy enough that everyone can understand it. But basically, we tied the input from bus 1 to the N1 pins of each of the 4 AND gates. That's what we see here. And then the same thing here for bus 2. Each wire from bus 2 is tied to the N2 pin of each of the AND gates. And then the output port of each of the AND gates is tied to one of the pins of the out bus. And let's hit Control Enter and check that out. Going to be a lot of test cases here. 27 test cases, and looks like it didn't do them all, but it did. No, it did do them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 20 to 27. That's not all of the test cases after all, but I guess it is. No, I'm sorry. I take it back. We're just looking at some of the test cases here on the screen. That it's obvious. And looks like 256 test cases. That's more like it. And every one of them passed. That's an excellent result. We click Enter. And we get a new design unlocked. Ted finished a design for us, which is the exclusive OR 4B. How about let's go down and take a look at that exclusive OR 4B. Is that interesting? He also did the OR 4B for us as well. So let's go take a look at those and see how much they look like the design we created. Oh, okay. So we only get the specification this time. We don't actually get to see Ted's design, but these work for us and saves us a lot of time. We've got some nice completed gates there. And one more task for us to do is the NOT 4B. This NOT 4B is has 2 buses, the in bus with 4 bits and the out bus with 4 bits. It's a very simple design. Let's take a look at it in digital. And we look NOT 4B. Open that up and you can see here all it is taking a NOT gate and tying an input to the NOT gate and the output to the NOT gate, one for each NOT gate, and it just goes straight through there. And in effect, each of the bits for the in bus is going to be flipped and sent to each of the pins of the out bus, just like that. So let's come back here and go get over to the design. And this is going to be pretty simple. We're going to in 1, 2, no, parts. I'm trying to wire it up already and we don't have all the parts yet. So NOT 1 is a NOT gate, and we want 4 of those. 1, 2, 3, 4. Change the names so they're all unique. And now we can wire it up. Keep wanting to use my mouse to get up there to move the cursor quickly, and mouse doesn't work in this program. Okay, now we're going to go in 1, 2, not one dot in, and we're going to do each knot by itself. So knot one dot out is going to go to out one, and that completes 1/4 of our design. So we need 4 of those, 1, 2, 3, and 4, and we'll go 2, 3, 4, and 2, 3, 4, and this is 2, 3, 4, and the out is 2, 3, 4, and hopefully you see what we've done there. We have the N1 to knot 1 in, knot 1 out to out 1, N2 to knot 2 in, and knot 2 out to out 2, N3 to knot 3 in, and knot 3 out to out 3, and N4 to knot 4 in, and knot 4 out to out 4, and so we should be ready to test that now. Click Control Enter, and again we see it passed. 16 test cases, and everything looks great. Isn't that nice? Click OK. And Ted finished another design for us, the Exclusive OR 16B. That is that's a 16-bit bus exclusive or a 16-bit bus exclusive OR. Now that's interesting. I want to see what the 16-bit bus looks like, and we'll have to go over there and take a look at that in a moment. It looks like it's under logic, completed logic circuits, and it doesn't even, oh, those are folders now. We've got more organization under completed so that we can find each of the parts more easily. That's good. All right, let's we've got a new design unlocked, and let's see, another design, the R16W. That is a 16-bit input for OR. And now this is an R16B. That's a OR 16-bit bits. And with using buses. Okay, then the AND 16B, NOT 16B, NAND 16B, and the NAND 4B have been unlocked. Now we've got a new task for our next video will be the half adder, and we've got also a demux task and a mux task, and those tasks are going to be an order of magnitude more complicated. I'll try to be prepared for each of those before we start. And so we're looking at the design specification, with the specification for the multiplexer. Interesting that it's put us there on the multiplexer, but our cursor is highlighting nothing. Okay, so but anyway, this we'll talk about what a multiplexer is and demultiplexer in our next video, and be prepared for some real interesting for a real interesting topic. If you haven't worked with the multiplex logic before, just prepared for a nice treat in the next video. Again, I want to encourage you, if you're a member of of uh, of, of STEAM, and especially if you are a senior citizen, I'd encourage you to look me up as Xcoder in STEAM Friends, and then look for my first name, Gil, and you should be able to find me in that way. Add me to your friends list. I'd like to meet you and be able to visit with you over in that program. So thanks again for watching. Come back again for our next session 4 of Microhard.